Earlier, we solved for the slope of the tangent line at x equals 1, where 1 could be here. Now, suppose x is a, where a is any real number. So that means at any point here, you are interested at finding the slope of that tangent line you drawn at x equals a. So a could be here, x equals a here. Okay, so this is a. Or your a could be here, that's a. Or your a could be here. So, how will we find the area, or how will we find the slope of the tangent line at any point A on the graph? Okay, so what we will do is to assume one point here, which is x equals A. So suppose this is our A, that's A, no? A yan. So this is x equals A. So we are interested at finding the slope of the tangent line here. So what is the slope of this tangent line? Again, we are looking at what is the slope of this tangent line at any A. So A could be 3, A could be 4, 5. Because the tangent line could be here, no? So x could be somewhere here, 5, 6. But in this case, it's just, let's just say it's A. So what we will do is we follow similar procedure as earlier, where we take points from the left of A or from the right. Now, let's try to use points from the right of A. So, for example, this is A, no? This is A. So we take values, let's say, you have here B. Our B is from the right of A. So that's B, no? So that's B. And let's make it like this. Okay, so that this is X plus B. So we are referring to this, no, point. So we have 2 points here, this one and this one. Okay. What are the coordinates of these points? Okay, so this point has coordinate. Let's say A, and then this is B. Point A and point B. So what do you think is the coordinate of A? So A has coordinate small a, comma, f of A. Okay, and that's the coordinate of A. And B has coordinate, because this is B, this is B, and then f of B, this is f of B, no? F of B. Okay? So, how will we find the slope of the second line? This is the second line, formed by connecting AB. What is the slope of that second line? Okay, so we can solve for the slope of the second line. We use again right over 4, right over run form of the slope. So we can have this one, f of b minus f of a all over b minus a. So x sub 2, y sub 2, x sub 1, y sub 1. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that's the slope. So similar idea, if we take this point very near to this point, the second line, no? If you look at the second line, okay, that is the second line that we are referring to. That's slope of AB. Okay, let me make this more specific. Slope AB. Slope of the line AB. No? Slope of the line AB. That's it. So if you take this point nearer, so what will happen is this, no? And then like that, like this. Okay, like this. And eventually, what will happen is it will come a time. There will come a time that the second line will superimpose the tangent line, right? And that will happen when the distance between this point here is very small. No? The distance between the two here is very small. Okay. So just like earlier, suppose we denote this distance to be h. Okay. So if we denote this distance between A and B as h, we may be able to find the relationship A plus h will be equal to B. So this is A plus h. That is just equal to B. A plus h, the result is B. Or again, we can express B in terms of that's B. No? B can be expressed as the sum of A and h. So what will happen to our formula? This will become f of B is equal to A plus h minus f of A all over B, that's A plus h minus A, or this is just f of A plus h minus f of A all over, that is just A, so you'll be left with h. And again, we can calculate for the value of f of A plus h. So we go back here, f of x is defined to that, so therefore f of A plus h is just equal to x, so A plus h, so you have A plus h squared, no? Minus, you have 3 here, x, this is our x, A plus h. So we can write it here, you have A plus h squared minus 3 times A plus h minus, of course, what is f of A? So if this is f of x, f of A is just equal to A squared minus 3A. Okay? So you have here A squared minus 3A all over h. So that is equal to, of course, you can simplify it, or you can expand the expression. The square root of A plus h, that's A squared plus 2AH plus h squared minus 3A minus 3h minus A squared plus 3A all over h. So listen, A squared, that's 0, minus 3A, so that's 0. So again, this is 0. This is also 0. So you'll be left with 2AH plus h squared minus 3h all over h. Okay, so common is h here, so you have h, you have 2a plus h minus 3. So that is equal to, this is 1, so you have 2a plus h minus 3. So this is the slope of the line AB. The slope of the line AB, 2a plus h minus 3. Okay. So I'll write this up in here. The slope of the line AB is just equal to 2a plus h minus 3. Now, we see earlier that if this h, the distance between A and B is very small, the second line AB will superimpose, no? Will superimpose, or will just duplicate the tangent line. This is our tangent line. So again, if you make your s smaller, that second line will eventually become the tangent line. No? That will happen only when you allow your edge to be very small, positively small. No? So what I mean by that, when h is very small, positively, when h approaches to 0, what will happen to this? What will happen to this expression? What will happen to that expression? What will happen to the slope of AB when h is 0 or when h is very near to 0? That will approach to 2a minus 3. That will just become 0, so that's 2a minus 3. And what is this? When h is very small, positively, you already have the slope of the tangent line. Slope of the tangent line. So that's the slope of the tangent line at A. So the answer here, so the slope of the tangent line at x equals A is, the slope is 2a minus